In this video, I shall show how to prove that if the midpoints of the adjacent sides of a square are joint, then it forms a square. So let's first consider a square. This is a square. Let's name it as ABCD. Now, the midpoints of the square are considered, which are P, Q, R and S respectively. And now they are joint. They are joint. And thus, a quadrilateral PQRS is formed. We have to show that this PQRS is also a square. So as you know, you have to first consider the given information. Let ABCD is a square, of which PQRS are respectively the midpoints of AB, BC, CD and DA. They are joined together and thus the quadrilateral PQRS is formed. You first have to consider all these given informations. Okay? Required to show that PQRS is a square. So here we have to show that the PQRS quadrilateral is actually a square. To prove the statement, we need a construction. What is that construction? We will just draw the diagonals of the square. So here the diagonals AC and BD are drawn and let they intersect each other at O. The diagonals AC and BD of the square ABCD are drawn. They bisect each other at O. Okay? Why we have drawn these diagonals? Because to prove the statement, we have to follow basically 3 steps. First of all, we shall show that PQRS is a parallelogram, that is, its opposite sides are equal and parallel. Secondly, we shall show that all the adjacent sides are equal in measurement. And thirdly, we shall show each angle, angle P, angle Q, angle R and angle S is 90 degree in measurement. So, first step is what? PQRS is a parallelogram. So, let's write down the steps for your convenience. PQRS is a parallelogram. Secondly, we have to show all adjacent sides are equal. But this is not enough because these two criterion are also followed by rhombus too. So now we have to show, in order to prove PQRS is a square, angle P equals to angle Q equals to angle R and angle S, all the angles individually equal to 90 degree. Okay? So let's begin. First of all, we shall show that PQRS is a parallelogram. Proof. Look, in triangle ABD, P and S are the midpoints of AB and AD respectively, right? P and S are the midpoints of AB and AD respectively. So can't we say from here by the statement of midpoint theorem, PS is equals to BD and PS is equals to half of BD and PS is parallel to BD. By midpoint theorem, PS is equals to half of BD and PS is parallel to BD by midpoint theorem. Let's make this relations as relation number 1, relation number 2. Similarly, if we consider triangle BCD, in triangle BCD, Q and R are the midpoints of BC and CD respectively. So BC and CD respectively. Similarly, we can say QR is equals to half of BD and QR is parallel to BD. These are relation number 3 and 4 respectively by midpoint theorem. So if you now combine 1 and 3, we'll get PS is equals to half of BD, QR is also equals to half of BD. So we can say from 1 and 3, PS equals to QR. Got it? Because both of them are equal to the same thing. PS is equals to half of BD. At the same time, QR is also equals to half of BD. PS equals to half of BD, QR equals to half of BD. And from 2 and 4, easily we can say PS is parallel to QR. Why? Because both of them are parallel to the same side BD. So PS is parallel to QR. So here we get PS equal to QR and PS is parallel to QR. And we know if in a quadrilateral, one pair of opposite sides are equal as well as parallel, so we can say that quadrilateral is a parallelogram. So PS equal to QR, PS parallel to QR. From this we can say PQRS is a parallelogram. PQRS is a parallelogram. So PQRS is a parallelogram. Hence the first part is done. Okay, where we had to show PQRS is a parallelogram. Now we will show that all adjacent sides are equal. Now for the second part, that is all adjacent sides are equal, we will consider these two sides first, PS and PQ, right? These are adjacent sides, you know, PS and PQ. Now look, this PS is parallel to BD. We have already shown this. And similarly, we can show that PQ is parallel to AC, right? PS is half of BD. At the same time, PS is half of AC. Okay. Now, we know AC is equals to BD as the diagonals of a square are equal in measurement. So, AC equals to BD means half of AC equals to half of BD. Now, half of AC means PQ, half of BD means ES. So easily we can show here PS equals to PQ. And similarly the other parts, other adjacent sides are equal can also be shown. So let's do this. Here we get that P and Q are the midpoints of AB as well as BC. So, by midpoint theorem, we can say PQ equals to half of AC. Let's take it as equation number 5, and PQ is parallel to AC. Let's take it as equation number 6. So now, just as we have already discussed, we have already seen that PQ equals to half of AC and PS equals to half of BD. So from 1 and 5, we get PS equals to half of BD and PQ equals to half of AC. Since BD equals to AC. Why? Because diagonals of a square are equal in measurement. We all know this. Therefore, half of BD is equals to half of AC. Therefore, PS equals to PQ. And what were PS and PQ? PS and PQ were the adjacent sides. So similarly, we can show PQ equals to QR, QR equals to RS, and RS equals to SP. So combining all these equalities, we can say PQ equals to QR equals to RS equals to SP. Okay, so all sides, all adjacent pair of adjacent sides of the quadrilateral PQRS are equal. Hence the second step is proved. Now let's consider the third part, where we have to show each angle is equals to 90 degree, right? How to show this? Look, we have already seen that PS is parallel to BD. Since PS is parallel to BD, okay, and PQ is parallel to AC, where BD and AC are the diagonals of the square ABCD, right? Diagonals of a square are perpendicular to each other. Therefore, AC and BD are perpendicular to each other. Now look, if AC and BD are perpendicular to each other, then obviously, suppose these are two lines which are perpendicular to each other, then obviously the lines which are parallel to them should also be perpendicular to each other, right? Because as the lines are parallel to each other, parallel to this perpendicular lines, so obviously they combiningly are forming a parallelogram, and we know opposite angles of a parallelogram are equal in measurement, so each angle should be 90 degree if the first two lines are perpendicular to each other. Therefore, as PS parallel to BD and PQ parallel to AC, so PS and PQ are also perpendicular to each other. That is, angle P equals to 90 degree. Similarly, we can show that angle Q, angle R, angle S, all the angles are equal to 90 degree. So, in quadrilateral PQRS, we have seen it's a parallelogram. All adjacent sides, adjacent pairs are equal in measurement and each angle is 90 degree. So from this relation, and from this relation, considering these three relations, we can say these three relations, that is parallelogram, adjacent pairs are equal and each angle 90 degree, we can conclude PQRS is a square. Hence it is proved. Hope the concept is clear to all of you.